Welcome to my mini talk about functional eradication. I'm Jeffrey Blumenthal, pronouns he, him, presenting on behalf of my co-authors listed here with their affiliations, and this video will be available on YouTube. Oyster restoration projects in San Francisco Bay have been impacted by invasive oyster drills like the ones shown on this restoration reef ball from 2017. The Olympia oyster is native to the West Coast and is the target of ongoing restoration efforts. The Atlantic oyster drill was accidentally introduced to San Francisco Bay in the late 1800s and is a voracious predator of hard-shelled organisms. The goals of the project were to quantify the impact of drills on oysters and to measure local populations, and experimentally determine whether drills can be managed effectively through functional eradication efforts using community participation. Functional eradication is reducing species populations to levels that have negligible to low ecological impacts. Based on previous studies, our target density was 5 drills per square meter. Our study location was 2 sites in Richardson Bay, California, a sub-embayment of San Francisco Bay. Our experimental design consisted of the hand removal of drills from the shoreline, a predator exclusion caging experiment, and shoreline biotic surveys. Community members participated in drill removal weekends in spring 2017 and 2018, and we counted the overall number of drills removed as well as catch per unit effort, or CPUE. To determine the effect of snail removal on oyster survival, we conducted a caging experiment using hatchery-reared oysters outplanted on ceramic tiles in the intertidal zone. Finally, we conducted quarterly surveys of experimental zones before and after removal events and at 4 additional nearby reference sites. Our survey results at the study and reference sites revealed negligible coexistence between oysters and drills, such that oysters and drills were effectively mutually exclusive in Richardson Bay. The results: over 300 participants volunteered over 450 hours and removed over 31,000 drills in 13 days. The impact of our removals on the drill population was mixed. At the first site, we achieved the target density at only 1 of 6 possible time points, and at the second site, we achieved the target density at only 3 of 7 possible time points. There was a large uptick of drills between spring removal events in both control plots, and a large uptick of drills at one of the removal plots. There was no evidence that CPUE changed over time at either site. If drill removal efforts had been successful in depleting the base population, we would have expected to see CPUE decreasing over time, which it did not. Oyster survival did not improve as a result of the drill removal. Survival was dependent only on caging treatment and not on removal treatment, nor their interactions. Survival in open plots was 0%, and half of outplanted oysters were drilled. Survival in partial caged plots was 1.6%, and 40% of outplanted oysters were drilled. And survival in caged plots was about 90%, and 0% of oysters in caged plots were drilled. Additionally, caged oysters exhibited high growth rates in addition to high survival, suggesting that environmental conditions were not a factor in the mortality of uncaged oysters. So overall, due to the large abundance of oyster drills and the difficulty of removing them, we cannot recommend functional eradication of drills as a management strategy at this time. It's hard to say precisely why it didn't work without a better mechanistic understanding of oyster drill population dynamics and limitations. Years elapsed since initial invasion could be a factor, and there is also ambivalence about what role drills' life history traits play in their colonizing or repopulating an area. And although we tried to preempt new broodstock by removing drills in the spring, it is possible that there were still overwintering drills that were not even reachable. It is also possible that the drill density bumps we observed were a reflection of interrupted ecological interactions, such as competition, that limit drill population. We also recommend more research into the potential for and limitations of natural predator enhancements as a control measure, for example, native rock crabs, which are known to eat drills in Tomales Bay. Bolstering oyster habitat may also benefit crabs, which may in turn control drill populations. We consider our project a success in terms of community engagement. The community exhibited a deep interest in invasive species and shoreline restoration, and this project could serve as a model for building public knowledge and support. Ongoing monitoring at a variety of sites around Central and South San Francisco Bay is also essential to determine if the invasion boundaries and populations are changing. And finally, we recommend focusing oyster restoration on areas of San Francisco Bay without drills and understanding the mechanisms that lead to success and failure there as they pertain to invasion potential. Many thanks to our funders, State Coastal Conservancy and Jason Payne, and our colleagues and interns and many volunteers.